question 6 is a word problem where you have to generate a quadratic and solve it. It says the length of the garden is 5 meters longer than its width. So I presume it's rectangular. So here we go, garden. So if I know the width is, say, x meters, then I know the length is going to be 5 meters longer. So x plus 5 meters. And I'm told that the area is 84 meters squared. So let's write it in there so I can remember and comprehend the context of the question. So then it says write down expressions for the length and width of the garden. Well, my length is x plus 5 and my width is x. I've done it. Use these to form a quadratic equation for the area. Okay, well, the area of a rectangle is base times height, or length times breadth. So x times x plus 5 will come to 84. Multiply out x squared plus 5x. Bring the 84 over and subtract it. Minus 84 equals 0. Find the length and width of the garden. Essentially, let's find x, shall we? So I'm hoping this will factorise, so it'll be really unkind if it doesn't. So x and x, now I'm getting scared. How do you make 84? 12 and 7. Does 12 and 7 give me a difference of 5? Yes, it does. So I'm happy I've got it. Put the 12 and 7 wherever you like. Right, I want to end up with a positive 5x. Therefore, I need the 12 to beat the 7. So 12 take away 7 is 5, and minus 7 times 12 is minus 84. I hope. So this is the lovely grade B quadratic as it goes, though it's sitting amongst grade A questions. So I've got x minus 7 equals 0, therefore x equals 7 meters. One solution. Now look at the next one. X plus 12 equals 0, so x equals minus 12. And next to that you write the word ignore. You ignore it because we don't have any negative lengths. Doesn't make sense. You have a length, and if you're underground, well, it's still a length, isn't it? So essentially x equals 7. Find the length and width of the garden. So therefore width equals 7 meters, and the length is going to be 7 plus 5, which is 12 meters. So we've got a rectangular garden, 12 by 7, and that's it. I'm going to pause the video and prepare question 7, I think, because it looks a bit tricky. Okay, this is me preparing question 7 on page 264. It says a box is made from taking a rectangular card. Well, that was the original rectangular card there, including the dotted lines to show where the little square's been cut out. And they've cut out a square in each of the corners, and the diagram is shown below. So what I've done is to construct this little box here. I've sort of cut it across there, there, and there, and fold it upwards. And this is how it would look if to fold it up and join it. Again, this is an open top box, so imagine that top face really isn't there. I can't show that. So I suppose I could do this, couldn't I, really? Just for prettiness. There to there, and there to there. Okay, an open top box, there it is. So this will become that if I was to join it together. Alright, so that's in context. Write down the expressions for the length, width and height of the box formed. Well, my length is going to be x plus 5, the long side there. My width is going to be x, that corresponds to that side there. And my height will be 1 centimetre just there. So that's the three things they want to do, the 3 dimensions. X for the width, x plus 5 for the length, and the height of 1 centimetre. All these lengths are given in centimetres in the question. Now for part B, I'm told the volume of the box is 14 centimetres cubed. So let's just write it down here. Volume equals 14 centimetre cubed. Guess what's going to happen? Form a quadratic, blah de blah de blah. Find the dimensions of the original piece of card. Oh, alright then. Right then, how do you do the volume of a box? Very straightforward. It's going to be the length multiplied by the width multiplied by the height, and this should all come to 14 centimetre cubed. Tie this up a little bit, ignore the 1, so if you multiply by 1, nothing changes. Multiply this out, I've got x squared plus 5x is 14. Create a quadratic, x squared plus 5x minus 14 equals 0. Factorise and solve. X and x makes x squared. 2 and 7 will make 14 if you multiply. 7 and 2 also have a difference of 5, so now I've got that right. in order to achieve 5 x's, I want plus 7 x's, take away 2 x's. Quick check. Again, always check before you go any further in case your factors are wrong, in case you've got the signs wrong. X times x, x squared, no problem. X times 7, 7x. Minus 2 times x, minus 2x. So I've got 7x minus 2x plus 5x works. And minus 2 times 7 is minus 14. So I'm confident this is correct. So I've got x minus 2 is 0, for which x equals 2 centimetres, or is it metres? Centimetres. And this will yield a negative result, which I'm going to ignore. But I'm still going to show that I've not missed it by doing this. So quote this one as well, equals minus 7, but be sure to write down the word ignore in it, because you don't want any negative lengths in the story. So x is 2. I'll just write down here quickly, x is 2. That equals 2 centimetres. And the question says, find the dimensions of the original piece of card. Well, all these are 1 centimetres. Just return. That's 1. That's 1. That's 1. And that's 1. So essentially, my piece of card is x plus 1 plus 1. Therefore, the width is going to be 2 plus 1 plus 1, which is going to give me 4 centimetres. And my length is going to be 1 plus 2 plus 5 plus 1. Just write it down. 1 plus 2, so of course x is 2, wherever you see it on the diagram, plus 5 plus 1. That gives us 9 centimetres. Is that correct? 3, 8, 9. Yeah. So therefore, the dimensions of the piece of card are 4 centimetres by 9 centimetres. That's a really beautiful question. I'll stop there because I've sort of tacked it onto question 6, so the video's getting a little bit long. I said I'll probably do question 8. I will do question 8. I'll study it first and get back to you. Okay, so that's it for now.